Hello, Algebra 2. This video lesson covers one more topic from Chapter 5 about quadratics. Up until now, we've talked about written quadratic expressions and how to factor them, or written quadratic equations and how to solve for x, or how to take that quadratic equation and graph it. But what if we want to work in the backwards direction? What if, and by the way, I'm sorry, this is going to talk only about page 306. That's the essential concept from chapter 5.8 that I want to make sure we cover. What if we're given the graph and we can see that it's a parabola and we're trying to work backwards and find out what's the quadratic equation that matches that curve? Well, if we can see the vertex, and in this case it's actually highlighted for us, it's at -3, -1, the easiest form is the vertex form of a quadratic to write that quadratic equation in. Remember our old friends h and k. So here is the generic or basic form of the vertex form. A, x minus h, all in parens, squared plus k. And remember, h is going to change its sign, and k is going to keep its sign. So I'm going to plug -3 and -1 in. -3 changed its sign and became +3. K kept its sign as -1. So now we've got the equation, except we don't know what a is. And remember, a controls two different things. It controls whether or not the parabola is upside down, like it is here, or right side up. And also it controls how wide it is. So we know the vertex is there, but what's the right a that makes it that direction rather than, say, that direction or that direction? And that's what we have to figure out. We have most of what we need, but not all. We've still got to find out what a is. Okay, well, at that point, the easiest way to find a is to take another point. Well, there's one right there. Take another point. That one happens to be -5, -5, and plug that in for the y and the x, so that the only thing that's not clearly declared is a itself. So here are -5, -5 in place of both y and x, and now we're going to solve for a. You should be able to go from this stage to realize I've actually got -5 equals 4a plus -1. Now if I rearrange everything and solve for a, I find that a is -1. It makes sense that it's negative because, after all, it is an upside down parabola. Now I simply plug that -1 back in place of a, and here's my equation. This is the quadratic equation for this curve. Okay. Now I'm going to move my work up here and give you another graph to look at. I'd like you to hit the pause button, follow along the steps that I've done here, and figure out for yourself what the quadratic equation is that matches this curve. Hit the pause button, as I said, and when you come back, I'm going to show you the right answer. Okay, I'm going to assume that you've paused and that you've worked this out. There's the answer. Y equals negative, in parens, x plus 2 squared plus 1. And here are the steps that you should have followed to figure that out. You start with the generic, but you plug in -2, 1, because -2, 1 is the vertex in, remembering that -2 changed its sign and became +2. And then you plugged in one more point. Well, you were given this one, 0, -3. So you plugged 0 in for x, -3 in for y. You rearranged the equation to solve for a, and you found that a turned out to be -1. And it would have been perfectly fine to have written -1 here rather than just negative. But the textbook and a lot of mathematicians usually are going to just forget about writing that 1 down and simply write negative out front. Okay, based on that, now here are two more for you to work on. The one on the left looks just like what you had just done. The one on the right is the same essential assignment, but there's no graph this time. In this case, and this is what your homework assignment tonight will look more like, you're simply told what the vertex is. It's -2, 1, and you're told a point that it goes through. Well, here you see what the vertex is, and you see another point that it goes through. So you have this same information over here, except we're actually getting visually to see the curve. But as the instructions here say, what you're supposed to do is tell what the quadratic function is in vertex form for this scenario. So I want you to solve both number 2 on the left and number 3 on the right. Hit the pause button. And when you come back, I'm going to show you the answers for both of those. Okay, I'm going to assume that you did that. And here are the answers for number 2 and number 3. And if those don't match what you got, I suggest that you pause, maybe go back to the work of the previous 2 examples and see if you can see where you made your error. Ask a classmate if that's the easiest way. Or next time we're together in class, I'd be happy to go over this with you. As I said, this is all from page 306. The other scenario is when you don't actually know what the vertex is, and it's a little hard for me to guesstimate what that vertex is precisely, but I do see the 2 places where it goes through the x-axis. In other words, the 2 x-intercepts. Well, intercept form of quadratics is the handiest for that kind of situation. And here we've got the generic version of intercept form written down. In place of that p and in place of that q, we're going to write those x-intercepts, which in this case are the x values of those points where the curve goes through the x-axis, so -3 and 5. So I've got x minus -3. This is going to turn into x plus 3. And I've got x minus 5. And once again, the one piece I don't have is a. So I know at this stage of the game that I've got, even if I didn't see so, I would know that I've got an equation that goes through those 2 intercepts, but I don't know what the factor is, the coefficient is out front that controls it being this steep. I can imagine a different parabola cutting through those same 2 points much more shallowly, looking like that. So how do I find out what A is? Well, once again, I'm going to plug in the coordinates of another point in for y and for x. And so there's one right there. It goes through the point 3, -3, so I'll put 3 in for x, -3 for y. So there's -3 for y and the 3 in for both of the x positions. I'm going to rearrange this equation just like the other one, and I'm going to solve for A. And you should be able to find that A turns out to be 1/4. Hit the pause button if you don't see immediately how I did this. I'm happy to talk it through if you need me to, but I suspect that you can work this out yourself. And so if A is 1/4, and up here I already had everything else I needed for the equation, then there's my equation. 1/4 x, remember, it did turn out to be plus 3, and times x minus 5. And once again, I'm going to move all of my work up here so that down here I can give you another one to try. And here you can see what the intercepts are. You'll have to identify the values of those intercepts yourself by looking closely at the graph, but you can also see another point that the curve goes through. Hit the pause button. When you come back, I'll show you the answer to number 5. Okay, I'm going to assume that you did that. And there's the answer to number 5. It's y equals x plus 2 times x minus 3. Notice there isn't really any A obvious here, but that's because A turns out to be 1. How did A turn out to be 1? Well, I went through the same step. I looked at the generic equation. In place of P, I plugged in -2, because that's, -2, because that's the x coordinate there. And I plugged in +3, because that's the x-intercept there. I then had to solve for A. In order to be able to solve for A, I had to plug in the coordinates of another point. 2, -4 was the one I was given, so I put in 2 for x in both those places and -4 for y. Solve this out, you'll find that A is 1. And if you had written 1 times x plus 2 times x minus 3, that would have been fine. Now that you've done that, Try these last two scenarios for yourself. Here, again, I've given you one where you can see the graph, and I've given you another one where you don't see the graph. Notice these are not the coordinates of one point. This is the x value of one of the x-intercepts, and this is the x value for another one of the x-intercepts. Just like over here, this would be, what is it? It looks like it's -4, and that one is 0. And this curve on the right goes through one more point, 328. Hit the pause button. When you come back, I'm going to show you the answers to both of those. Okay, I'm going to assume that you did that. And there are those answers. Notice the one on the left might not look like what you'd written down. The one on the right, I hope you do have. I hope you have something just like this. You might have had x plus 4 in the left parens and x plus 1 on the right, but that doesn't matter. Over here, though, you may have written this as minus, and in parens, x minus 0 times x plus 4. This is perfectly fine, too. The textbook simply collapsed this down. It figured that there's no point in saying x minus 0. Just call that x. And if you only have x here, then you don't need parens, and it becomes minus x. So this minus x is really saying the same thing as minus times parens x minus 0. And that's it for this video lesson. I have one separate one about how to use the graphing calculator to do much of the same sort of work, but for now, that's where we're going to stop, and I'll look forward to seeing you the next time I'm in class, and I'll be happy to answer any questions that you have.